OPC UA for plastics and rubber machinery. Today we have here Dr. Mikola Thiem from our VDMA Plastic and Rubber Machinery Association, and we also have Jürgen Peters from Aarburg. And we will learn today more about what is OPC UA in the plastic and rubber machinery area and what companion specifications are already available and maybe also which are in development. So Mikola and Mr. Peters, the stage is yours.
Thank you very much, Andreas, and welcome from my side to our presentation today. I will switch to the agenda. Sorry. So this is the agenda for today. First, I will give you an introduction into the domain of plastics and rubber machinery. After that, I will give you an overview about the history of standardization in this industry. Then we will have a detailed look into the OPC 40082 series and the information model. And after that comes Jürgen Peters from Aarburg with an example from the practice about fully integrated peripherals with OPC UA. Now let's start with the introduction into the domain. When we talk about plastics and rubber machinery, we talk about a large variety of machine types. And I try to cluster these machine types into three different groups. And the first group I named machines to process plastics or rubber. And this means the machine uses raw material and produces finished or part finished products from that. And this machine group, there are injection molding machines, which you can see on the picture, with a discontinuous production process for, again, a large variety of parts. Almost every plastic part can be produced there. Then in the group, there are also extruders with a continuous production process for, let's say, extrusion of endless profiles like tubes or pipes or window profiles, but also very important plastic film and tubes for packaging. Then there are compression molding machines for large sheets of plastic, like automotive body parts, for example. Then there are also thermoforming presses for cups and bowls, tire curing presses for tires, obviously, particle foam machines for example, styrofoam for building insulation or packaging, and also blow molding machines are another machine types for bottles and canisters, for example. The second group in this domain is the peripheral devices who interact with a production machine. And this is what you can see here. The peripheral devices are mostly attached to the machine itself or near the machine and interact with the machine during the production process. And there are, for example, handling robots for insert and take out of products from the machine, temperature control devices, which are very important because almost every production process with plastic involves heat and temperature. Then there are hot runners, which are often combined with the molds. A dosing system for the correct dosage of raw material into the machine, dryers for the material condition, and much more like the extrusion line peripheral devices like haul-off, saw, calender, corrugator. There are much more. And then there is a machine group which handle the finished or part finished products. For example, winders, what you can see here in the picture for the winding of plastic film into large rolls, or foam cutting machines for the production of mattresses, for example. Ultrasonic welding devices to join two halves, for example, for the product. And recycling machines and material supply systems to handle material from an entry point up to the delivery to the machine. Of course, these lists I've shown you are incomplete, just to give you an overview about the variety in the plastics and rubber machinery industry. And this industry is very familiar with the topic of standardization because standardization of plastics and rubber machinery is done in so-called EUROMAP technical recommendations. And EUROMAP is an umbrella association of the European manufacturers of plastics and rubber machines. And as you can see here on the right side, with the member associations, the German part of EUROMAP is VDMA plastics and rubber machines. So there we are directly involved. And these technical recommendations are the standardization of this industry, and this started more than 40 years ago. So the famous EUROMAP 1 was published in 1983. And this is the standardized description of injection molding machines. You can see there is standardized what parameters are relevant in the clamping unit or in the injection unit. How are these parameters determined, and in which unit should they be given in, for example, technical data sheets. And another point in this EUROMAP 1 is the EUROMAP size indication. This is a suffix to the machine name and is a combination of the clamping force and the injection volume. And this specification is still valid today. And this, can you see here, this is an extract from an Arburg technical data sheet. And there you see that with the machine name, there's also the EUROMAP size designation, which shows that this specification is still valid and used even today. And also the communication of data is standardized in EUROMAP technical recommendations. And this started in 1993, so more than 30 years ago. There were the EUROMAP 15, the first specification for a data communication standard. And this is a protocol between injection molding machines and a central computer. And this is based on the technology of that time. This is based on bit bus. But the parameters which were communicated with this specification are similar to the parameters you will find today in OPC UA. So you have the machine identification with the manufacturer name, for example, and process values like parts counter and cycle values. And with computers getting more and more performant, there was a need to develop a new specification for data communication, and this was done in the year 2000 with the EUROMAP 63. This is a successor of the EUROMAP 15, and this is a file-based communication standard with a binary large object, and you have a communication like you send a request file and you get a response file back with information about the last cycle and every information what you need to for the production process. And this EUROMAP 63 is still in use today, so you will find all over the world injection molding machines which have the EUROMAP 63 implemented. And with the rise of information technology, the working group met again in 2014 to find a successor of EUROMAP 63 with a modern information technology. And this group decided to use OPC UA for that, and so started to develop a recommendation and a standard. And this led to a memorandum of understanding between the OPC Foundation and EUROMAP in the year 2016. And this MOU was the start of the joint working group Plastics and Rubber Machinery, which is today the working group responsible for all the OPC UA Companion Specifications for plastics and rubber. And this MOU also stated that the specifications are released identically as EUROMAP and OPC versions. In the same year, 2016, the first release candidate of the OPC 40077 injection molding machine to MES was published. And during discussion and comments, the group realized that this specification contains multiple objects and object types which are not only valid for injection molding machines, but also for other machine types. And for that reason, a new specification was developed, the OPC 40083 general types for plastics and rubber. And 1 year later, both specifications, the OPC 40077, which is the same as the EUROMAP 77, and the OPC 40083 were released in the version 1.00. And since then, multiple specifications have been developed in this working group. We have the first two is the 40083 with the general types, with objects, variables, and methods valid for multiple machine types, and the 40077 for the communication between injection molding machine to MES with machine configuration, process values, job management, and so on. And then we have a whole specification series for the extrusion line. This is the OPC 40084 series. This consists of total 12 parts. So every component has its own part. You have the extruder itself, the haul-off, the saw, pelletizer, and so on. 12 parts again. And of course, used for process values and remote control in the extrusion line. Then we have another specification series, the 40082 for peripheral devices. And there we will have a detailed look in a few minutes into that. And then there are two specifications in release candidate state. One is the 40079 injection molding machine to robot. And this specification is used for the real-time handling coordination, because it's very important that the robot is not in the mold area when the mold is closing. So we are talking about reaction times of milliseconds. And this is the reason that this specification doesn't use classical client-server communication, but PubSub, which is rather complex to implement. And then we have the 40086 material supply systems. And this specification is for the order management and tracking of material from an entry point of a system up to the delivery to the machine. And beside these published specifications, we have multiple specifications where we are working on. We have multiple active working groups for different machine types. There is the 40087 for particle foam machines, the 40089 for drying systems. This is for, say, rather more large drying systems or plants where a product is or flows through different heating zones or curing zones to get dried, which might be also suitable for example, paper machines or an automotive paint shop, for example. Then we have further parts in the extrusion line for inline measurement systems, and another part in the peripheral devices where we started the granular dryers. Then we have the 40091 specifications where we're working on for winding systems, for rewinders and unwinders. And this is used for winders for plastic films and tubes, but could also be used on paper machines, for example, because printed paper is often also wound on rolls. And then we started this year a new specification series, 40092, for flexible pure foam production and processing. And there we started with part 1, cutting machines. So you see there's a lot of work we're actually working on, and you can expect multiple specifications to be released soon in our industry. And this is the hierarchy of specifications. We have on the bottom the OPC UA meter model and the built-in information models from the UA core. On top of that, we use OPC UA for machinery in every new specification. On top of that, we have the OPC 40083 general types for plastics and rubber. And on the top level, we have the device type specific companion specifications. Now, with this overview of existing specifications and specifications to come, I want to give you a detailed look into the OPC 40082 series and the information model. So, as I said earlier, the OPC 40082 series is for peripheral devices. And each device has its own part. So we have at the moment 3 parts published. This is part 1, temperature control devices, part 2, hot runner, and part 3, liquid silicone rubber dosing systems. Recently, we released 2 further release candidates, part 4, dosing system for granulate dosing systems or powder or liquids, basically everything which is not liquid silicone rubber, because that's another application. And we have a new specification released for molds, part 5. And then we started recently part 6, the working group for granulate dryer devices for material conditioning. The use cases in this series are always similar. So first of all, the communication plan is the specification can be used for the communication from the peripheral device to the production machine, of course, for process optimization and production process in general. But also you could connect from a superordinary computer system like MES or SCADA to the peripheral device. And by this, you don't have to send the process values to the production machine, and from the production machine to MES, you can connect directly. And the variables or the data, what we communicate with this specification is generally information about the device and its condition, process monitoring and control by, for example, writing of set values by the connected machine, or methods to switch on and off, for example, the machine. Then we have often a method or a function to log in or automatically log in the machine user on all peripheral devices which are connected, which makes it easy for the operator. And often we also have some production dataset management to be able to send a production dataset as a black box with standardized metadata. Now, I would like to give you an example of one information model. This is the top level of the information model of the 40082 part 1 for temperature control devices. But as I said, all parts of the specification look rather similar. So we have, first of all, we often have, or every time have, an identification object. And as you can see here, in this case, the identification is from the identification type. The index 3 is the OPC 40083 general types. And in new parts of the series, or in general, all new parts of our joint working group will use OPC UA for machinery, the machine identification type for identification. The reason here is that this specification was released before OPC UA for machinery existed. Then we often have a device type specific configuration type, like here the TCD specification with device type specific parameters. Here it is maximum temperature, nominal flow rate, for example. Then we have a machine configuration type, also from the OPC 40083, where the user can give his own configuration values, like an own given name, or he can define this as a time zone where the machine is located, or give a user-specific location like Hall A, Factory B, and this is in this type. Then we have an operation type with parameters necessary to operate the device. See here, for example, the switch on and off method. And there we often also have arrow handling, or a parts counter, or in this case, operation hours counter. And here in this specification, we also have the state as the operating mode. And in future specifications, or all new specifications, will use also the OPC UA for machinery, the machinery item state, to give the state information. And then there is always one object type with device type specific process monitoring and control parameters. And this is often, or in most cases, the most extensive part or object here. And this is what you see here. it's not meant that you have to read every parameter and variable which you see here. I just want to show you this is the device zone type of this temperature control device specification. And in this type, there are the important parameters or the parameters needed for process monitoring and control. And for a temperature control device, of course, the temperature is very important. And this temperature is, as you can see here, from the control parameter type. That is a subtype of the monitor parameter type, which are both defined in the 40,083 general types for plastics and rubber. And these types provide the actual value, set values, to low limits, to high limits, and alarms to monitor these limits. And for all who are familiar with the OPC UA for machinery, you will know that this is very similar to the new process value type in OPC UA for machinery part 2. And for that reason, in every new part, we will use the process value type for these process monitoring and device. And then there are also other parameters there where only one single value is relevant, like the standby temperature or actual regulation ratio. And for these variables, we use the analog item type. And in new parts, we will use subtypes of that, like the analog unit type or the analog unit range type. Then we often have in this device type specific part maintenance. The maintenance itself is also defined in the OPC 40,083, but in this case we have 4 instances for heating, cooling, pump, and fluid. And then we have several methods like switch on and off of external channels or mold evacuation. This is, of course, depending on the device type. And this is the, it was just to give you an overview of the device type specific process monitoring and control object type. And before I now hand over to Jürgen Peters from Aarburg, I want to give you just one example I found which shows the benefits of OPC UA for the end user. And this is an example from a real operating manual of a hot runner. And this operating manual has a chapter which is called data communication. And the first part is serial data communication with RS485. And there's written, please carefully refer to the manual of your machine manufacturer as a general hint. And if you want to wire this device to an Aarburg injection molding machine, you have to map these signals from these pins to pin 2 and 3, and please check the Aarburg documentation for the correct baud rate. And if you want to connect it to a FANUC machine, you have you need a special box with a special cable, and you need these signals to map on this signal. And please refer to the FANUC documentation for the correct setup. And if you want to connect it to an angle, you need another protocol. And of course, you have to look into an angle documentation for the correct setup. And chapter 4 in this operating manual is data communication with OPC UA. And there is written, this controller has an integrated OPC UA server and fully supports OPC 40,082 part 2. And the next sentence, the user does not need to configure anything. And this, in my opinion, shows the benefits of the end user for OPC UA. This is the best advertisement for OPC UA you could get. And with that being said, I am on the end of my part of the presentation, and now I would like to hand over to Jürgen Peters from Aarburg to give us some insights.
So, welcome to the second part of the presentation about the benefits of fully integrated peripherals. My name is Jürgen Peters. I am Director of Software Development at Aarburg with more than 30 years of experience in controller technology. Aarburg is a manufacturer of injection molding machines with its headquarters in southern Germany. But one of the most important things you need to know about Aarburg today is that we have a developed team with more than 10 years experience in OPC UA technology. And since many years, we have been a member of different VDMA working groups. So, why standardization for peripherals is so important? Since material and plastic parts becoming more and more complex, also the mold technology increasing rapidly. For example, because of the number of cavities, the mold getting more and more complex. And because we already provide a lot of functionality in our IMM controller, it isn't sufficient for complex process. And in compare to the past, where we need no or less external peripheral devices, today we need much more device and different device types for complex processes. That means that we will have much more process parameters. And with the existing protocols and technologies, this isn't possible. And for this, a new standard was required and also new specifications for each peripheral device type. And this was the beginning of the OPC UA in the EUROMAP standardization, as Mikola team said before. So how could an integration look like in practical? For this, we need OPC UA implementation. And what are the requirements for this? In order to use OPC UA, first we need an OPC UA software development kit. With this tool, we could develop and integrate the necessary communication modules and models. Toolkits are offered by various commercial providers as well as free open source tools. So generally, a server provides data and the client requests data. So in our case, the peripheral devices need to implement a server which can provide data to an IMM, and an IMM needs a client to receive this data from the peripheral device. So what are the challenges for the integration? As Nicola team said before, 2016, about 8 years ago, the plastic industry have been decided by using OPC UA for peripheral devices because this technology offers a lot of advantages. But in our first steps, we had a lot of big problems with the integration of OPC UA. One reason was that the suppliers will start with their development. Most of the device controllers was not able to integrate an OPC UA server because their controller has less CPU performance and or less memory. For us as an IMM, injection molding machine producer, it's not so relevant because our CPU performance was good enough. And the second challenge was that the development teams of the suppliers has less or no experience about OPC UA technology. So first, they had to upgrade their hardware systems, and then they have learned step by step how to integrate an OPC UA technology. So, but today, most of the suppliers' controllers are prepared for OPC UA. So the next question, how should we connect the peripherals? And how could we make an easy connect between an IMM and different peripheral devices? And in compare to the past, we will have only one technology and only one plug type for all device types. And how could we do this? After many discussions in the working groups, we could not find a solution for all and for a specific plug type. So we from Marburg side decided to use a standard connector with a M12 plug for secure and safe connection. And if we want to connect more than one device, we use an N-fold switches. But this definition is not part of the OPC specification. not yet. So what's about the network configuration? This was the next challenge. How could we easily connect several devices in one network? Because our customers and users are no network specialists. For this, we needed a practical and an easy solution. And all peripheral devices should be in one network. And also, after many discussions in the working groups, we defined to use DHCP for an easy network configuration. Here you can see, as an example from our controller, how the network configuration could look like with 6 temperature control units or 3 hot runner systems. So you make only plug and play, and the device type will be recognized and will automatically get an IP address. So it's very easy to connect the different device types to an IMM. But what are exactly now the benefits for the users? For us, we set all relevant settings from the peripheral, which are from the mold or from the material dependent. We can visualize on the IMM panel from all device types. We can modify directly at the IMM controller, and we can store together in the IMM dataset. That means that we can also make an import-export from the complete dataset to an MES system. And in addition, also alarms from the peripherals are shown and stored centrally. We can start and stop the production centralized from the IMM, and the device parameters has the same look and feel like the IMM parameters, so the user don't need to know different controller systems or UI interfaces. And from the technology side, we have nearly unlimited device and parameters. And if we need much more information about the device, we can make a connection via VNC or with a web browser to make remote control for the device. So in the next step, I will give an overview of the various specifications, as you can see before from Mikola team. In the first part, we can see the 3 different standards which we have already integrated. So we have the specification for multi-temperature control, for hot runner system, and also for the silicon dosing unit. And if you are more interested in details, you can find it on the EUROMAP.org homepage or on the VDMA homepage as well. But then we have another specification more for dosing, mold monitoring, and trial systems. And as also Mikola team said before, the 82.4 for the dosing system, we already have a release candidate in this quarter 24. For the mold monitoring, the 82.5, this one is defined, but has not yet been launched. And for the 82.6, we expect also a release candidate at the end of the year. And also for the general information, we had 83. Now I would like to show you examples from our real practice. For this, I have prepared 3 different examples from our Arbor controller, how we integrated mold temperature devices or hot runner systems or a silicon dosing unit. The first example shows the integration of 6 mold temperature control units with the EUROMAP 82.1 or the OPC 40082. The big advantage here is the amount of the device, which can communicate at the same time via OPC UA. Here you can see that we have 6 different devices. And for example, ARBORG supports up to 26 devices at one injection molding machine. And with existing protocols, this is not possible. So the second example showed the integration of a hot runner device with the 82.2. The advantages here is the amount of heating zones which we can handle via OPC UA in compared to existing technologies like the 20 milliampere or CAN bus. From the technology side, there is no limit. Today, we at ARBORG, for example, support up to 300 heating zones via the 82.2 in our IMM controller. And this is a big amount of heating zones. And in my last example, the third one, we can see integration of the silicon dosing unit with the 82.3. In the past, we only had a digital I/O interface for a ready signal, for alarm signal, and a trigger signal for start dosing. But now with the OPC UA, we have all relevant process parameters on the IMM panel to visualize. We can change the parameters and we can store it together with the data set. And the silicon dosing unit, we can also operate it directly from the IMM controller. So we can start and stop from the IMM, the silicon dosing unit. So, and finally, I will show you a list of suppliers which ARBORG has already validated. Here you can see a list of the 3 existing peripheral specifications, the 1, 2, and 3. So in total, ARBORG validated already nearly 20 different suppliers. And as the next step, here you can see a list of the suppliers where ARBORG are in contact with for further specifications. That means for the 4, 5, and 6. These suppliers also recognized the advantages of the OPC UA and have started or would like to implement a OPC interface. And ARBORG has already realized first prototypes together with some of these suppliers to practice with. So, and what are the next steps at ARBORG? So, we have communicated a proposal for the 82.6 specifications to the VDMA and the working groups. We start with the 82.5 specification for mold monitoring, where we already have first experience with the company HEC. We shown it on several exhibitions. And in coordination with suppliers and customers, we want now to start to define manufacturer-dependent parameter areas. Because not every supplier using the same technology, the customer needs to configure parameters with special properties. Then our IMM controller can recognize the device type and could show or could hide these special parameters depends of the device type. And in the next step, we want to make a proposal for a secure communication between IMM and peripherals devices, because OPC UA offers a lot of existing secure technologies. So thank you for your attention. That's from my side.